So sensors basically in the wild. So what happens when the sensors are actually in the real world? So everything is very nice in laboratory conditions or in the office, but as soon as we put them in the real world, things can happen. And this is a compilation of some recommendations that we have been facing in our experience. So general considerations. Now you have, or as they come, you have basically bare probes, either with short or long cables. But basically the sensors cannot just, or the probes cannot just simply be submerged and be left unprotected, because they are very delicate and they can get damaged. You need something to protect them, and also in case that you want to measure at a certain depth, you have to have something that keeps them at that depth, and that if you have a very long cable, the probe doesn't just simply move with the currents. The probes need to be accessible or accessed periodically for maintenance, which is quite important because maintenance, as we have seen, is very, very frequent for some of them. And even we said that the pH probe has a 3-month recalibration interval, but we will see that it's in some cases you need to clean the probes even weekly or bi-weekly. So you have to be able to access the probes. And in case that you have an enclosure, you shouldn't place an enclosure that contaminates the environment, of course, and also affect the reading. So if you're using some sort of plastics, we recommend low reactivity plastics such as HDPE, PVC, even if we don't like it, but it's a very good plastic, or ASA or ABS. In case that you're using it in seawater, since seawater is corrosive, make sure that you use stainless steel with marine grade. And consider also that in largest masses or bodies of water, the tides change. So sensors basically will be not submerged, or depth basically will change. So if you leave them very close to the surface, maybe the tide will rise or go down, and then the sensor will be left measuring in the air. And of course, you need to at least submerge the sensor at the tide lowest point, at least. So in terms of enclosure, to install the sensor, we have 2 options. Of course, these have not been delivered, and you currently have bare probes. But we basically have 2 proposals for enclosures that we can also provide some components for, especially the 3D printed components in ASA. That then can be used to deploy the sensors. We have 2 different types of enclosure. One that is more bulky, but that is good for shallow or deep deployments, and is basically containing all the sensors in the same bulk of PVC pipe, or what we call a spear type of enclosure, in which you have the sensors along a very thin pipe, roughly 30 millimeters, and placed with, let's say, parts that hold the sensors onto the pipe. And this is a good idea in case that you have small spaces and you need somewhat deep deployment. So maybe down to 5 meters, something like that. It is interesting to use this type. Otherwise, the bulk type, if you want to leave the sensors for deeper depths, or for higher depths. Probably one of the most limiting and important aspects of the maintenance is what we call biofouling, which implies basically this. So if you are deploying sensors in seawater or freshwater, but that there's a lot of biological activity, you will basically see something like this, which is sensors covered with biomatter. which is maybe shells, maybe algae, maybe aquatic plants, maybe other things. And of course, other types of oils and many substances can get attached to the sensors. So it depends on the area. You might have to get the sensors out and clean them. And in some cases, for instance, in Barcelona, some sensors have to be taken out and cleaned in a weekly basis so that they don't get basically readings that are not representative because of the presence of biomass in front of them. This, of course, depends on the deployment, but you have to consider this cleaning in a very in a very frequent basis in some cases, and also plan it along with the recalibration that you will have to perform in some cases also frequently, either 2 or 3 months in some situations. This is also important because the type of deployment that you do, it also is going to determine how accessible the sensors are, or how easy for you to access the sensors to clean them is going to be. And make sure that the sensors are accessible, because this is going to happen quite often. More specific to the probes, the pH probe, in case it's dirty, it will lead to erroneous reading, and a coating or anything that is around the bulb, the glass bulb, and that will basically affect the readings. If the coatings or the, let's say, whatever is covering this bulb is soft, you can simply use distilled water and let's say stirring it in distilled water, or as squares bottle. This is very common in labs. Or in case you have organic chemical or harder coatings, you can use light diluted bleach solutions. But do not use brushes or toothbrushes or sandpaper or anything like that to remove the coating. Use chemicals to remove it. And depending on the type of coating, soft, simply just stirring it with distilled water, or chemical, organic, or hard with some chemicals. Particular base solutions could help. If after recalibrating you see that the probe doesn't work, then you might have to apply reconditioning. And in the Atlas Scientific documentation, there's information on how to do this. But never use brushes or hard sanding paper, because they will basically kill and destroy the probe. Conductivity probe is very simple. It can be simply cleaned with a brush, and make sure that in the crevice in here there's no accumulation of dirt. But basically just consider that anything that is stored in there will affect the readings. And just using a soft brush, you can remove any coating in it. For the self-oxygen probe, the preparation and the maintenance is the same. So you have to refill the electrolyte solution, you have to sand the zinc oxide that accumulates on the probe, and you have to clean the membrane, but use a very soft brush for that. And you have to do this roughly every 4 to 6 months to have the readings comply, let's say, with your requirements. And similar to the pH probe, the ORP probe will accumulate or have coatings, so the same type of processes apply in terms of soft versus organic or harder coatings. Do not use sandpaper, but in this case you can use a soft brush to clean it. And maybe some hydrochloric acid soaking will also help to remove many coatings as well.